Good afternoon, everyone. Today I will going to start explain the laws of photoelectric effect in different cases. See here, effect of potential on photoelectric current. Okay. So what is the effect of potential on photoelectric current? See, in a photoelectric effect experiment, cathode and anodes are connected like this across a variable source. This is a variable source. Okay. Across a variable source like this. Across a variable source. Okay. When a suitable wavelength of the light radiation is incident on the metal surface, what happening is there? So the electrons are ejected like this. The electrons are ejected from this emitter. So when we had applied across a potential V, what happening is there? The potential has a here, this is a negative terminal. This is a negative terminal, right? It has a negative terminal at this point. It has a negative terminal. It has a positive terminal here. So the electrons are ejected from the metal surface due to this applying potential. Okay. If the potential is increased, what happening is there? The emission of electrons are increased like this. The emission of electrons are increased. When the emission of electrons are increased, what happening is there? The flow of the current in the circuit would be increases because of the collection of the collector. This is this emitter and this is nothing collector. Due to collection of the collector of the electron, the photoelectric current has to be increased. Okay. When we had applied here, the potential is applied. What happening is that immediately some amount of electrons are ejected. So these all electrons will be reached from the emitter to collector. They would be produce the maximum amount of current. So in the circuit. So when we have drawn the graph across, what is that drawn across the electrostatic potential and emission of the electrons and flow of the intensity of current, it would be like is there. Okay, right? See here. This is when we had applied potential here. What potential? V0 potential we had applied like this. What happening is there? All the emitted electrons are gradually increased from emitter to collector. That means the flow of the current in the circuit is also gradually increased. So the here see the electrons here started here. Okay, the electrons will be gradually increased from the emitter to collector. So that's what the current also in the circuit also gradually increased like this. When the current is increased gradually, at certain particular applied potential, what happening is that the current would become a maximum. This current is called as a what current? This current is called as a saturation current. This is a saturation current. This is a saturation current. This is nothing but a applied potential or anode potential. This is the current I am taking on y-axis and applied potential I have taken on x-axis. Then what happening is the graph will be gives like this. So this current is called as a what current? This is called as a saturation current. Okay. So this experiment is repeated for using the higher intensities of light by keeping its frequencies constant. Then the graph will be like is there. The graph would be like is. Here see in the above case what I'm doing see here. If the intensity of the light is gradually increased, here this is a cathode and anode here beta. Okay. So cathode and anode, they are connected like this. What happening is that the intensity of the light is gradually increased. The intensity of light is gradually increased. Higher intensities of light. This light has the intensity is I1. This light has the intensity is I2, and this light has a intensity I3. Where what happening is that I1 intensity of light can be emits some electrons and I2 also emits the electrons and I3 also emits the electrons. These emission of the electrons can be produced the respect of their currents in a circuit. Okay. We had applied some amount of the potential V0 also. Here see. In the same case, what happening is there? In the same scenario, see here, I1 would be what happening is that the I1 would be when a stopping potential or potential or when a stopping potential is applied here, what happening is that I1 would be emit the what is that current, saturation current like this. This is a I1. Next to this when I2 light is incident on this metal surface, it can be also emit some amount of the current. That would be the what is that? This is I'm again drawing. See here. Okay. Here see. When I1 intensity of light is used, it can be emit the current like this here. It can be emit the current with a potential of V naught. This is I1 intensity of light. Next, I2 intensity of light is also emits the current. This is also I3 intensity of light is emits the current. This is the intensity of I1 and I2 and I3. These I1, I2 intensities are produced at different currents I across what is that? Across emitter and collector. Okay, is it clear? Now, this is the potential. What potential? The potential is taken on x-axis. X-axis is the potential is taken on x-axis, and electric current is taken on y-axis. If the intensity of the light is increased, and that means different intensity of lights are incident on the emitter. On the emitter, this is nothing but emitter. They would be produce the different types of the currents. They would be emits the different types of the currents. So those currents also gradually increase like this. Experimentally, it is observed that different intensities of the lights are having the same stopping potential V naught. This is called a stopping potential. No? Different intensities of the lights are having the same stopping potential V naught. So from the graph, it is very clear that what is that here? I1, I3 is greater than to I2 is greater than to I1. So this intensity is more comparing to this. So this intensity more comparing to this. This is a relation between the intensities of the lights. Okay, by increasing the current. Okay, this is a graph between V naught and I. Even though the intensities of the currents are changes here. Okay, next to see. In the same scenario, I'm taking what is this is a cathode and this is nothing but anode or emitter and collector I have taken like this. Okay. Emitter and collector I have taken like this. Already we have drawn this one. You see. In the previous case, see. So the electrons are ejected here at this emitter. Initially, the electrons have the electrostatic potential energy or potential energy. When they are ejected, the potential energy would be converted into kinetic energy. I am considering this point. I'm considering this point here. See, I'm considering this point. See, so the electrons are ejected like this. I'm considering this point, or this point, or this point. Any one of the point I'm taking here. See, here generally the electrons are revolving around the nucleus like this. The electrons are revolving around the nucleus with a nuclear attraction force is already known. Okay. So between them, what kind of the energy would be possessed? Electrostatic potential energy or EV naught will be possessing. When the ray of light is incident on this, what happening is that the electron would be emitting. This electrostatic potential energy or the potential energy of the electron would be converting. What is the kinetic energy? Ke max. That is called Ke max is equal to half mv square. So according to law of conservation of energy, the entire electrostatic potential energy has to be converted into maximum kinetic energy. Therefore, in this case, EV naught would be is equal to half mv square maximum. Therefore, the potential would be, we can written as like this, that is equal to half mv square max upon E. This is called as a applied potential or stopping potential across cathode and anode. Okay, is it clear? Next, in the second case, effect of frequency of light on potential. Effect of frequency of light. In the second case, effect of frequency. Effect of frequency of incident light Effect of frequency of incident light. Incident light on potential. On potential. In the second case, is effect of incident light, frequency of incident light on potential. So consider the same, what is that photoelectric experiment, which is connected to a certain potential like this, V naught. Okay, here intensity of light is keeping constant. Intensity of light, I is going to keeping constant. When the frequency of the light is changes like this, when the frequency of light is changes, this is a F1 and this is a F2, this is a F3. When the different frequencies of the light radiations or incident on the emitter, then what happening is that the electrons would be released from this and reach the collector like this. The electrons would be released and reach the collector. This is the collector. Hence, what happening is that the photoelectric current will be flows in the circuit. The photoelectric current I will be flows in the circuit. Okay. When we have taken the emission of the current on y-axis and potential on x-axis, so different frequencies are changed. Different frequencies are having the different stopping potentials in this case. See here, when we have drawn the graph between, I and V naught, okay, first F1 frequency has to be incident on this. What happening is that, and F2 frequency also incident on this. It can be emits the different electrons here like this. Different electrons, that means different density of electrons, they would be produced the different currents here. Here see, intensity of light is keeping the constant here. This is an intensity of light. Intensity of light is keeping the constant here. Okay. Here I is equal to constant. When F1 frequency has to be incident, it can be produced, what is that, at a stopping potential of V01 from this. When F2 frequency of light is incident on this, here it has a stopping potential is V02. Okay. When F3 intensity of the light is incident on this, it can be produced, what is that, stopping potential is V03. That means this is a F1 frequency of light, this is a F2 frequency of light, this is a F3 frequency of light. Different frequencies are having the different stopping potential here. Okay, different frequencies of lights are having the different stopping potential. So from the graph, it is very clear that F3 is greater than 2, F2 is greater than 2, F1, V03 greater than 2, V02 greater than 2, V01. So this is the relation between what is that stopping potentials and frequency. That means from this graph, it is very clear that F is the direct proportional to V. F3 is direct proportional to V3. F2 is direct proportional to V2. So F1 is direct proportional to V1. Means the stopping potential is direct proportional to what is that? Its frequency of incident light. Is it clear or not? The frequency of incident light is direct proportional to stopping potential. Okay. So when we have taken this metal has to be changing. If the metal emitter I am changing and draw the graph for different types of the metals, the relation between the frequency and stopping potential will give like this. Yes, see. I'm taking what is the stopping potential on y-axis and frequency is on x-axis. Okay, is it clear? I have changed it here. This metal A have taken first one. In this photoelectric effect, what was taken? First of all, I have taken metal A. It has a frequency F1. Okay. When a ray of light is incident on this F1 frequency of light is incident, applying the stopping potential is V1. The stopping potential will be is equal to V1. So here, when you have drawn the graph here, at the origin, the electrons does not emitted, For all the frequencies are could not be able to the electrons already, in the photoelectric effect loss already we did lengths. So for the metal A, for the A metal I am using. For the A metal, what happening is that F is direct proportional to V naught is already in the previous case. So for the F1 is direct proportional to what is that? For metal A or first metal as your wish, any one of the take. What is that? Here we have the frequencies of F01 or F1 take here. Next, from the instead of the metal 1, I am using metal 2 or metal B. Here, instead of the metal A, I am used here metal B. Metal B, I have taken metal B taken here. It's a metal B taken. Instead of the metal A, I have taken metal B. So this is disconnected here. It's a disconnected like this. Metal B I have taken. Again, the frequency of incident light, what is that on this? On this, what was the incident here saying? On this F2 frequency of light is instant on this. It would be emitted some amount of electrons like this. It can be produced some amount of photoelectric current. So when we have drawn the graph across the stopping potential and F, it will be given like this. It is also give the straight line only. It's a metal. This is a metal B. So it has the frequency is called what is that? F2 and stopping potential should be is equal to V2. Okay. Where F1 is must be greater than to F2. Is it clear or not? So this is a graph between stopping potentials and different frequencies of incident light. Okay, these are the different cases. In 2024 में क्वेश्चन पूछा बेटा, see here. JEE मेंस में क्या दिया 2024 में 2024 graphical का क्वेश्चन पूछा ऐसे. Here one graph was given like this. It has different intensities. Okay, I1 and I2. And second graph was given like this. Different intensities here, beta. This is I1 and I2. This is a V01 and V02. Okay. Next, the third graph was given like this. Now, third graph was given like this. This is a third graph was given like this. This is a I1 and this is a I2. The third graph was given like this. This is I1 and this is I2. I1 and I2. It's a photoelectric current I and applied potential V0 was given like this. Thus, the photoelectric current was given I. Potential V0 was given. This is also I given. Emission of the current. In this case also what was given, see. In this case also potential V0 was given and current I was given. What happened is, what is the effect of potential and photoelectric current was given as follows in the graph. These are intensities are given. Intensities of light. This is the intensity. This is the intensity of fan lights. Of fan lights was given. These are the intensities of fan lights. Intensities of fan lights. Intensity of fan lights. See, and this option 1 was given, option 2, and option 3. The fourth one is none of these. None of these was given. None of these. So, which is the correct option? Bolo. From the out of these 4 options, which is the correct option? Effect of potential on intensity of light. Find which graphs are gives the correct for the effect of potential on intensity of light. Effect of potential on intensity of light. Which one is you see? It's a V01 given here. V01, here V02, here V01 and V02 given, and none of this. Which one is the correct? See, already we have explained in the first one only. What happening? Effect of potential and intensity of electric light. different lights are having what is that? Different higher intensities of the lights having the same constant potential. Constant potential difference only. Constant potential difference. That means constant stopping potential difference. So the first one is the correct answer. Here see, intensity of I1 and different intensities of the light have the constant potential difference. But whereas in the second case, different intensities of the lights are having the different stopping potentials. So it is not correct. Next, the third one say different intensities of the lights are having the same stopping potential. But here experimentally it was found. But here was given different intensities of the lights having the different stopping potentials. So it is also wrong only. So this first one only is correct. Is it clear? Okay. Next say the next concept is the most important Einstein photoelectric effect. Photoelectric effect. Einstein photoelectric effect. So very important for the JEE mains and advanced also. Okay. Einstein photoelectric effect. What is an Einstein photoelectric effect? Einstein was taken, what is that? Alkyl metals, he was considered alkyl metals only. W. Smith and Edge was could not be explain how would be the electrons are emitted from the metals, or alkyl metals or inalkyl metals. But Einstein was concluded, he was studied about the photoelectric equation, and he was given the mathematical statement for the emission of the electrons from their orbit. He was considered only alkyl metals only, not inalkyl metals. Alkyl metals means what are the alkyl metals? If a metal consisting of a single electron on its outermost orbit is called as an alkyl metals. Example, what are the alkyl metals? Example, see. Example alkyl metals. Examples for the alkyl metals are sodium, lithium, potassium, and C. These are called as an alkyl metals. See. Suppose consider a sodium. Here, sodium take sodium. Write the electronic configuration for the sodium is 1s2, 2s2, 2p6, and 3s1. This is the electronic configuration of an sodium. So the sodium of outermost orbit is consisting of only single electron only. 3s1 means single electron only. Okay. When a electromagnetic light or electromagnetic wave is incident on the metal surface, or when a photon is incident on the metal surface, what happening is there? Suppose consider a metal here better. This is a metal. Metal I say, this is a metal. Okay. This is a metal. This is a metal. When a photon is incident, when a photon of energy E is equal to h nu, E is equal to h nu is incident on the metal surface, what happening is there? From the metal surface, electrons are ejected. From the metal surface, electrons are ejected. So this energy E is equal to HF. This E is equal to HF. HF energy has to be incident on the metal surface. From the metal surface, electrons are ejected. So this incident energy for an electron can be utilized into two ways. How many ways already we know? So here, initially the electron is the electron is revolving around the nucleus like this. Initially, the electron will be revolving around the nucleus like this. Okay, with an electrostatic force of attraction. So between them, what happening is that electrostatic energy is there. Okay, when this photon energy is incident. When this photon energy is incident on this metal surface, what happening is that this energy can be utilized into two ways. First one is the work done. That means work done to break up the bond, and remaining energy can be utilized into recoil the electron from its orbit with maximum kinetic energy. K max is equal to half m v square max. Is it clear? Therefore, the total amount of energy E can be written as what is that? E is equal to first one, it can be utilized in two ways. Work function W naught plus half m v square max. So this is called as a Einstein photoelectric equation. Okay. The amount of energy for the photon can be utilized in two ways. First one is breakup from its nuclear attraction force, and second one is its kinetic energy. E is equal to W naught plus half mv square. Or simply what I am writing here, E is equal to W naught plus Ke max. This is called as a Ke max. Or this also what I am writing here, HF is equal to HF naught plus Ke max. K max, where nu in the last class I have taken nu naught plus I am taking F naught, nu plus I am taking F frequency. Okay, so K max I am writing in the form of Ke max is equal to, what is the K max? K max is equal to HF minus HF naught. Is it clear? So from this, the kinetic energy of an electron, Ke max is equal to, or Ke max is equal to what I am writing, this is Sc by lambda, Sc by lambda minus Sc upon lambda naught, and Ke max is equal to, you can take Sc, that is 1 by lambda minus 1 by lambda naught. What is this value? This value also already know. Ke is equal to 12,400 electron volts into 1 by lambda minus 1 by lambda naught. This is the kinetic energy of an electron in the form of kinetic energy of an electron in the form of electron volts. Okay. If the electron would be starts to recoil, then what happening is that this energy, electrical, the potential energy would be, which is equal to kinetic energy. Okay. Then the electron would be tends to recoil from in its orbit. In this case, K max is equal to what is that? K max is equal to EV naught हो जाता. K max is equal to EV naught. K max is equal to EV naught means, then the equation would be E is equal to W naught plus EV naught हो जाता. So W naught is called as a work function. What is that called? Work function. Work function. Where V naught is called as a stopping potential. V naught is called as stopping potential. This is called as an Einstein photoelectric equation. The mathematical expression was given by the Einstein. How he was given? See here, the energy of the energy of the instant photon or an electron here can be utilized into two ways. First one is the work done energy. Second one is the maximum. The total amount of energy of photon can be utilized into two ways for an electron. First one is the work done energy, and second one is the kinetic energy. And these are called as a mathematical form. That is, the amount of energy incident would be equal to W naught plus half mv square max. So from this K half mv square means K maximum. So maximum kinetic energy है. That is HF is equal to H naught plus K max. K max would be equal to like this. Okay, understood or not? Below, I hope that you may be understood about this concept. Okay, based on the concept C, J problems or J advanced problems, C or J means and advanced problems. Okay, by keeping the work function of a metal is constant. Work function of a metal, suppose consider a metal है बेटा, it's a metal. So metal का work function would be kept at constant. That is work function omega naught is equal to constant. Okay. When a photon of energy E and it has the frequency 2f naught. When a photon of energy F is equal to 2f naught is incident on a metal surface. From the metal surface, an electron is recoiled with a velocity of v1. Okay. Next, another photon of energy E2, it has energy E1 here, better. E1, it has energy E1. Okay, it has energy E1. It has energy E1, E1, and frequency is the 2f naught is instance on the metal surface. On the metal surface, an electron is recoiled with a velocity of v1. Okay. Next, another photon having the energy E2. This is another photon having the energy E2. E2 and frequency phi f naught. It has a frequency phi f naught is on the metal surface. An electron is ejected with a velocity v2. An electron is ejected with velocity v2. Electron is ejected here with a velocity of v2. Then find the ratios of the velocities of an electrons in the two cases. Okay, this is a JEE mains problem here. JEE mains. JEE problem here. JEE problem. Okay. Find the ratios of the velocities of an electron. Find the ratios of velocities of find the ratio of velocities of an electrons in the two cases. Find the ratios of velocities of an electron in the two cases. Okay, see here. Here we have to use what is that Einstein photoelectric equation matter. What is the Einstein photoelectric equation? E is equal to W plus of mv square. ठीक है. So this is what I'm getting. See, half mv square would be is equal to half mv square is equal to E minus W. That is equal to HF minus HF naught. W means what is the W? So W naught is equal to HF naught. Okay, metal of the work function remains constant only. In the first case, see, half m v1 square is the first case is equal to HF1 minus HF naught. HF1 minus HF naught. But in the first case, F1 is equal to what was given better? F1 is equal to 2F naught given. That is half m v1 square is equal to H into 2F naught minus HF naught. In this case, half m v square is equal to v1 square is equal to HF naught minus HF naught means this is equal to HF naught. Let's take this equation number 1. Okay. In the second case, in the case 2, this is a case 1 take. Case 1. This is a case 1. And this is in the case 2. What happening is the same scenario you can use half mv square, half mv2 square is equal to HF2 minus HF naught. That is half m v2 square is equal to HF2 value was given phi f naught minus HF naught, that is equal to 4F naught. What should we have to calculate? The ratios of their velocities. Let's take this order we have taken this equation number 1. Let's take this equation number 2. 1 upon 2 implies 1 is equal to half m v1 square upon half m v2 square would be is equal to 1 is HF naught upon 4 HF naught. F naught and F naught will be gets cancelled out. M by 2 gets cancelled out. V1 upon V2 is equal to root over 1 upon 4, that is equal to 1 by 2. Therefore, V1 is 2, V2 is equal to 1 is to 2. This is the final answer. Okay. बहुत आसान प्रॉब्लम पूछा बेटा. दिस इज जेईई 2024 का क्वेश्चन है. ठीक है. नेक्स्ट सी, नेक्स्ट प्रॉब्लम इज जेईई 2025 है बेटा. वो जेईई मेंस 2025. What was given here? When the intensity of light is increased on a metal surface. When the intensity of light is increased, by keeping the intensity of the light is, by keeping the frequency is constant, when the intensity of light is increased on the metal surface, so what happening? The emission, what happening? The photoelectric current in a circuit. Okay, that was the question. Here, what happening is there? This is emitter. Direct, I am single plate only taking here. Okay, और नहीं तो पूरा ले कोई प्रॉब्लम नहीं. This is emitter है बेटा, emitter है. Okay, this is a emitter, this is a collector. So when the intensity of light has to be increased here, I is increased. When the intensity of light has increased, what will be the constant? By keeping the F is equal to constant, the intensity of the light is increased. So how would be the photoelectric current? It changes. How would be the photoelectric current? It changes in the circuit. How would be the photoelectric current? It changes in the circuit. Okay, by keeping the frequency is constant, by keeping the frequency is constant, if the intensity of the light is increased, if the intensity of light is increased, how will be the photoelectric current changes? How will be the photoelectric current changes in the circuit? Yes, see, by keeping the frequencies constant, if the intensity of light is increased, then what happening is that how would be the photoelectric current changes? Yes, see. This photon, the light electromagnetic wave has a, what is that? So many number of photons say beta. This is I am taking here, this plate I am taking here. See, when one photon is incident, one photon of energy E incident, so one electron is emitted. When another photon is incident, one more electron is emits. Okay. Another photon, third photon is incident. That means the third electron is emits. That means the emission of the electrons is direct proportional to the number of photons incidents on a metal surface. Therefore, the intensity of light we can be written as I is equal to, what is that? I is equal to N E by A into T. Is it correct? When I is increases, I is direct proportional to N. Okay. When I is increases, the number of photons incidents on the metal plates also increases. When the number of photons incidents on the metal plates is increased, so the emission of electrons from the emission of electrons from the emitter also increases like this. The emission of electrons from the emitter also increases. When the emission of electrons from the emitter is increased, the photoelectric current in the circuit would be increased. That means when the intensity of light is increased, the number of photons also increases. When the number of photons are increased, what happening is the emission of electrons from the emitter also increases. When the emission of electrons from the emitter is increased, what happening is the photoelectric current is also in the circuit is increases. Is it clear? Is it clear or not? बहुत आसान प्रॉब्लम है. और 2025 में पूछे how would be the photoelectric current is changes by keeping its frequency of incident light is constant. If it is intensity is gradually intensity is increase. That means the photoelectric current also increases. This was the option. Okay, this was the answer. Next problem C. On the same concept, the photoelectric current is better. Suppose consider a mirror. This is a mirror. Suppose consider a mirror is better. This is a mirror. A mirror is suspended with this is a mirror M, which is suspended with Moseleys string. Moseleys string of one end is fixed at this point, and other end is connected. And the other end is connected here, beta, of the mirror here. Or mirror. This is a mirror. Okay. When a laser light of energy incident on the mirror, this is a laser light. When a laser light of energy having the energy E is equal to HF is incident on the mirror, then what happening is there, the mirror would be deflected through a small angle theta with the vertical like this. The mirror has to be displaced like this through a small angle theta. The mirror has to be displaced through a small angle theta with the vertical. Then find the value of the theta. Find the value of the theta. This was the question. It was asked in JEE 2025 beta. JEE 2025. Both the awesome problem here. Laser light here, that means photon only. When it is incident on the mirror has to be deflected with a small angle theta. Then calculate the value of theta beta here. Here the length of the string was given. What is the length of the string? Let's take the length of the string would be is equal to L. Okay. The length of the string would be is equal to L. When it is deflected like this length does not change. It would be remains constant only. Okay. The mirror is initially at this position is there. The mirror is initially at this position is there, right? When the this energy is instanced on the mirror initially it has to got some amount of kinetic energy. That is K is equal to of mv square. Is it clear? Then due to this kinetic energy, what happening is that the mirror has to be raised a certain height of h from this initial position. Is it clear? That means this kinetic energy has to be converted into here potential energy. Then calculate the value of theta in this case. Okay. How much height was raised? We don't know. Let's take the mirror has to be raised to a height of h. These two are parallel lines. This is a height h means this is also as height h only. Okay. The remaining length would be equal to what is the remaining length? This is a L minus h is the remaining length. This length is nothing but L only. This point is D. This point is P for that means final position. In this case, I have to calculate what is this height. How much height it was raised. This height I have to calculate now. Height h. Okay. How would be the height calculated? See how we will have to calculate the height h. So from this triangle ODP, from this triangle is very clear that cos theta is equal to what is the cos theta? Cos theta is equal to adjacent side upon hypotenuse. Let's take this angle 90 degrees. No, it is 90 degrees. It will be hypotenuse. Cos theta is equal to L minus h upon L hoga adjacent side upon hypotenuse. Is it clear? So L minus h would be equal to L minus h is equal to L cos theta hai beta. From this h is equal to L minus L cos theta. H is equal to L into 1 minus cos theta. This much height it was raised. Okay. With what height it has raised? This much height it was raised. Let's take the mass of the mirror is nothing but M here. Okay. This at the initial position, the mirror has only kinetic energy only, right? Mirror has a kinetic energy only. This kinetic energy would be converted into potential energy. According to law of conservation of energy, initial energy K, initial energy EI is equal to EF. Both will be equal. Initially, the mirror has only kinetic energy only. What is that? Of M V square is equal to, finally potential energy is equal to mgh hai na? This kinetic energy has converted into potential energy, that is mgh. Therefore, half mv square is equal to, what is that? mg into h. What is h? L into 1 minus cos theta. Okay, 1 minus cos theta. But this photon has instant on this. How would be its momentum has changes there? What would be the momentum has changes? The changing momentum of the photon is given by delta P is equal to, is already know, 2E by C. The change in momentum of the photon, delta P is equal to 2E by C. This is what I am writing MV. MV is equal to 2E by C. With what velocity the mirror was started? With velocity V is equal to 2E upon MC. With this velocity, the mirror was started at this initial position. Is it clear? Okay. That you have to substitute here. What you will getting see here? Of mv square. Of m into v value is 2e by 2e upon mc whole square is equal to mgl into 1 minus cos theta in the form of 1 minus cos theta. We have to write in the form of 1 minus cos theta is equal to 2 sin square theta by 2. 2 sin square theta by 2. Is it clear? For small angles, sin theta is approximately equal to theta. This is what I'm going to see of m into 4e square upon m square c is equal to mgl into 2 into theta by 2 of 4 square. Theta is very small. For small angle, sin theta is approximately equal to theta by 2. Okay. So 1 m and m gets cancelled out. 2 ones are 2 twos are 2e square, v square upon mc square. Okay. 2e square upon mc square is equal to mgl 2e into theta square upon char 2 ones are 2 twos are 4. That is 2e square upon mc square is equal to mgl into theta square by 2. We have to calculate the value of theta here, beta. How we will calculate the value of theta? See here, theta square is equal to what I am writing, see, 4e square. It will be going to 4e square upon m square c square into g l. M into m, g into l. Therefore, theta would be is equal to root over 4e square upon m square c square into g l. Okay. So from theta is, what is the value of theta? Theta is equal to 2e upon mc into root gl. Theta is equal to 2e into mc into root over gl. This much angular displacement it would be made the mirror. Is it clear? I hope that you may be understood. This is a advanced level problem. So J may पूछेगा. See once again see problem. A laser light of energy is equal to h nu hf is instant on a mirror. I showed in figure. If the mirror is deflected with a vertical angle theta, then calculate the value of theta. Laser light is consisting of a so many number of photons, no? That means photon only. When it is incident on this, what happens is that the change in momentum would be given by delta P is equal to 2E by C. Delta P means change in momentum, that is mass into velocity is equal to E by C. From this V is equal to E by MC. With that velocity, the mirror has to be started here. With that velocity, the mirror has got some k is equal to half m square. Okay. With that velocity, it has started and it has to went. What is that? A maximum height of h from the initial position. So in this case, we have to calculate what is that the angular displacement which it is made at the what is that at the suspension point or suspending point. So you can use law of conservation of energy. Initial energy is equal to final energy. That is, initial energy means the mirror has a kinetic energy of m square, potential energy mg into this is we have calculated. And here v value also substitute here and simplified. We have to got theta is equal to e upon m into root g. Is it clear? Is it clear or not? बहुत आसान प्रॉब्लम है, नोट करो, नोट करो बेटा. Next problem, see. Next JEE problem है. JEE 2025 का problem है. Okay. A photon of energy is incident on a metal surface in a photoelectric experiment like this. This is a photoelectric experiment है बेटा. Okay. A photon of energy is incident on this like this. A photon of energy is equal to HF is incident on the emitter. Okay. An electron is ejected like this. An electron is ejected from this with certain velocity. Across the electron, what happening is there? A magnetic field has to be applied like this. A magnetic field. This is a magnetic field. This is a north pole. This is a north pole, and this is a south pole. Is applied like this. A magnetic field is applied like this, perpendicular to an electron. A magnetic field B is applied perpendicular to an electron. This is south pole है बेटा. This is south pole है. This is south pole. This is a north pole. North pole like this. South and north poles are applied like this. Then what happening is that the electron has to be completed one circle in the field. Then find the diameter of this circle. D is equal to how much? Is it clear problem? Find the diameter of the circle I showed in the figure. Find the diameter of the circle I showed in figure. Okay. This is only I am considering here. Only this part only I am considering here. What happening is that where D is equal to our diameter, let's take this circular path. The electron has to be compared to the circular path. Our diameter would be equal to D. D is the, let's take 2R. The radius of the circle will be take R. D is equal to 2R. When an electron of mass M, it has a certain amount of mass now. Electron has a mass M and charge Q. So charge Q, when it is entering a magnetic field, what happening is that it has completed one circle. Therefore, the radius path of the electron is given by R is equal to mv by qb is already known. R is equal to mv by qb. But what is the diameter? Diameter D is equal to 2R no. That is for 2 into mv upon qb. mv upon qb. Is it clear? Therefore, the diameter would be is equal to D is equal to 2P into QBM rating. What is the P? P means momentum of an electron. Therefore, the momentum of an electron is given by K is equal to what is that? K is equal to P square by 2M. From this P is equal to root over 2m into k e. This much momentum it can be possessed. Here see, when the electron is instanced on this metal surface, okay, the energy of an electron can be utilized into two ways. Now here first, E is equal to what is that? W plus Ke, or that is equal to W plus of m v square. Of m v square. Of m v square. This is what I am writing. Of m v square is equal to E minus W लिखो. That is called P square upon 2m is equal to E minus W हो गए. From this, what is the momentum? P is equal to root over क्या होगा बेटा मैंने? P is 2m into E minus W. This is what I'm writing. See, P is equal to root over 2m into HF minus W. E minus W लिखो. E minus W है. This is the value of P. The moment of P is equal to E is equal to 2m into root over E minus W. That is the value of P. Value of P है ना? Okay. Value of P है. वो इसमें लगो D is equal to, that is D is equal to what you will getting 2 by QB into root over what is the value of P? 2m into E minus W है बेटा. That is D is equal to 2 upon QB into root over 2m into HF minus H F naught हो जाते. That is equal to 2 by QB into root over 2m into SC by lambda minus SC by lambda naught. So this is a diameter of the circle. Is it clear? The diameter of the circle is given by this much. D is equal to 2 by QB into root over 2m into S by lambda, SC by lambda minus SC by lambda naught. बहुत आसान problem है. This question was asked based on the concept of Einstein photoelectric equation only. Problem see once again. In a Einstein photoelectric equation, a photon of energy is equal to h nu incident on a emitter. Okay. The electron is emitted with certain velocity v. Okay. When it is emitted some amount of velocity across the electron, the magnetic field of induction B is applied here, perpendicular to its motion. Then find the diameter made by the electron in that magnetic field. This is we have to calculate D is equal to what? Okay. When the electron is entered in a uniform magnetic field of induction B, what happening is it has some radius R is equal to mv by qb है बेटा. For the diameter D is equal to R, that is 2R into mv by qb. That is D is equal to 2p by qb. But P value also already we have calculated. This is P value. This value substituted here. Okay. Then what you will get is what we have got here. P is equal to 2 by qb into root over 2m into SC by lambda minus SC by lambda naught. Is it clear? Okay. Note करो बेटा. Next, next concept is the de Broglie waves. De Broglie waves. De Broglie waves or de Broglie waves. De Broglie waves of a matter. De Broglie waves of a matter. Or de Broglie waves. Of a matter. Or matter waves. These are the called as de Broglie waves of a matter or matter waves. De Broglie waves or matter waves. Okay. What are the de Broglie waves? De Broglie waves means suppose consider a matter है बेटा. This is a matter. This is a matter है. So matter. This is matter. Okay. When a ray of light is interact, when a ray of light is interact with the matter, it's a ray of light. Ray of light. When a ray of light is interact with matter, sometimes it is behaves like sometimes it is behaves like what is that? Sometimes it is behaves like a particle nature. Sometimes it is behaves like a particle nature. Particle nature. And sometimes it is behaves like a wave nature. Sometimes it behaves like a wave nature. When a ray of light is interacted with a matter, this is a matter. Okay. When a ray of light is interacted with a matter like this, sometimes it is behaves like a particle nature. Okay. Sometimes it behaves like a wave nature. This multi-nature of light is called as a dual nature of radiation. What is that? Dual nature of radiation. This is called as a dual nature of radiation. So these waves are called as matter waves or de Broglie waves. When a ray of light is interacted with the matter, sometimes it is behaves like a particle nature, and sometimes it is behaves like a wave nature. This multi-nature of the light is called as a dual nature of light, and these waves are called as a de Broglie. It was found by the de Broglie. That's what these waves are called as de Broglie waves. Okay. So according to the Einstein energy equivalent equation, so the light has some wavelength is lambda. The photon has some amount of energy. The energy of the photon is given by E is equal to mc square. E is equal to mc square. That is equal to mc into c. That is p into c. Okay. E is equal to mc square. P into c. This is the p is equal to what I am writing. E upon c. But E is equal to h nu here, or E is equal to what is that? H nu or hf upon c. Okay, but C is equal to U lambda, already know. But C is equal to F lambda. Okay. F upon C is equal to what is that? F upon C is equal to 1 by lambda. Therefore, the momentum of the photon is given by E is equal to what is that? H by lambda. Lambda is equal to H upon P. That is called H upon MV or MC. This also MV or MC. These are called as H by MC or H upon lambda is called, what is the lambda? Where lambda is equal to, what is the lambda is equal to H upon P, that is equal to H upon M P. This is called as a de Broglie wavelength. This is called as de Broglie wavelength. Is it clear? Is it clear or not? See, when a light is interacted with the matter, sometimes it behaves like a wave nature and sometimes it behaves like a particle nature. Okay. When it behaves like a particle nature, the energy of the photon is equal to mc square. But when it behaves like a wave nature, what is that? C is equal to F lambda. Lambda is equal to, what is the lambda? C is equal to F lambda. Lambda is equal to C upon F beta. So this is a wave nature and this is a particle nature. So from these two combinations, de Broglie was derived wavelength. That wavelength is called as a de Broglie wavelength. That is lambda is called H upon D. That is H upon MV. Okay. So when it was taken in experimentally, see here. When it was taken in experimentally, see. When it was taken experimentally, see here. across the emitter and collector, what happening is that a potential V is applied here, right? V naught is applied. When the electron is ejected with the maximum kinetic energy E or with the maximum velocity V, therefore, before emitting this cathode, before emitting the emitter, the electron has a electrostatic potential energy or electrical energy, potential energy EV naught. EV naught is equal to half mv square, that is equal to Ke is already known. Therefore, the de Broglie wavelength can be written as lambda is equal to h by mv. No, lambda is equal to h by mv. Therefore, the de Broglie wavelength was given lambda is equal to h upon mv. But the kinetic energy of an electron is given by K is equal to P square upon 2m. From this P is equal to root over 2m into Ke. Therefore, the lambda of the particle or electron is given by h upon root over 2m into Ke. This is the de Broglie wavelength in the form of kinetic energy of a particle. So, in the form of potential energy, but EV naught is equal to what is that? Ke. Therefore, the wavelength would be lambda is equal to h upon root over 2m into EV naught ho jata hai. This is a EV naught. This is a EV naught. Okay. This is a EV naught. From this, lambda is direct proportional to what is that? Lambda is inversely proportional to what is that? Root V naught ko barabar hai. V naught is called as a stopping potential. Okay. From this, lambda 1 upon lambda 2 is equal to, for different particles, lambda 1 upon lambda 2 is equal to, what should we have to write? M2 root over M2 upon M1 into V02 upon V01 ho jata hai. These are the wavelengths here, beta. These are called as the wavelengths. But here, what is the value where H is called as a Planck's constant here? H is called as Planck's constant. The Planck's constant was calculated by the what is that Einstein only according to its equation. How can he was calculated Planck's constant? See, E is equal to what is that? E is equal to W plus Ke है ना of m square, that is equal to Ke. EV naught है ना, बोलो. That is EV naught is equal to what is that? EV naught is equal to E minus W. That is equal to HF. E is equal to HF. HF minus W होगा. ठीक है. That is V naught is equal to what is the value of V naught? H upon E into F minus W upon E. Okay. This is the stopping potential. This is looking like a Y is equal to what is that? Mx plus C now. Okay. Mx plus C. What is the M? M is equal to slope. Slope of the graph is equal to H upon E. Okay. It was explained only Einstein only. Okay. This graph I'm drawing, I am see the graph between potential and frequency. Frequency and potential. Stopping potential I'm drawing like this. So what is the slope of the graph? The slope of the graph is equal to H by E here. The slope of the graph will be given like this. The slope of the graph will be like this. This is called as what is this value? The constant value. What is the constant value? The constant is equal to minus W by E is called as the constant. Okay. This is the angle. Theta hai beta. What is the slope of the graph? Slope of the graph tan theta is equal to M is equal to tan theta is equal to H upon E, where H is equal to E into tan theta. So from this H value has to be calculated experimentally. What is that? 6.62 into 10 to the power of minus 34 joule second. This is a calculation of, sorry. H value has calculated H is equal to what is that? 6.62 into 10 to the power of minus 34 joule second. Okay. So it was used in the de Broglie wavelength. What is lambda is equal to H upon root over 2m into K E. Okay. This is the process of calculation of the Planck's constant. I hope that you may be understood. Okay. Okay. Tomorrow we will discuss the problems on the de Broglie wavelength. Okay. Today concept, what did I explain today concept? In that concept, you have any doubts? Please ask me on the scrolling number.
Right, unmute it.
Okay. So sir, call me.
సో ఇప్పటివరకు జరిగిన క్లాస్ లో మీకేమైనా డౌట్లు ఉంటే సిరుపూర్టి గర్ల్స్ కానీ లేకపోతే మిగతా స్కూల్స్ కానీ చాలా శ్రద్ధగా చదువు అంటే వింటున్నారు, అన్ని విన్నారు కాబట్టి మీ డౌట్లు ఉంటే ఇప్పుడు మీరు అన్మ్యూట్ చేసి సిఓఈ వరంగల్ తర్వాత చాలా స్కూల్స్ మంచిగా వీడియోస్ ఆన్ చేసి శ్రద్ధగా ఎంతసేపు విన్నారు కదా, మీకు ఇప్పుడు ఎటువంటి డౌట్స్ ఉన్నా దయచేసి అన్మ్యూట్ చేసి మీ డౌట్స్ అడగగలరు. As of now, the class went very well and many of them have been turned on their videos and then they were listening very good. So now I request if you have any doubts, so what has been class have been taught. So if you have any doubt, please unmute yourself and clarify your doubts. దయచేసి మీ డౌట్స్ ని మీరు క్లారిఫై చేసుకోండి. డౌట్స్ ని క్లారిఫై చేసుకోకపోతే అవి అలానే ఉండిపోతాయి, మీరు క్లాస్ విని వేస్ట్ అయిపోతాయి. సో దయచేసి సార్ కూడా రెడీగా ఉన్నాడు, సార్ కూడా మీకోసం వెయిట్ చేస్తున్నాడు, మీరు అడ్మిట్ చేసి మీ డౌట్స్ ని క్లారిఫై చేసుకోండి. ఎవరికి ఎటువంటి డౌట్స్ లేవా అండి? దమ్మాపేట్, వరంగల్ గర్ల్స్, సిఓఈ, నాకు తెలియదు సార్. ఓకే దెన్ మీకు ఎటువంటి డౌట్స్ లేకపోతే దెన్ వీఆర్ క్లోజింగ్ ది సెషన్. ఉన్నాయండి డౌట్స్? సిఓఈ వరంగల్ గర్ల్స్ నవ్వుతున్నారు, ఏమైనా డౌట్స్ ఉన్నాయా లేవా?
No sir.
COE Warangal. Okay.
Okay, done. Thank you so much.